When a quadratic equation is expressed in this form here, that is that it equals 0, we can use the discriminant to determine the number of roots. The number of roots being the number of times that the graph crosses the x-axis, or when y equals 0. In this graph we have 2 roots. Here the curve touches the x-axis in one unique place, so there's only one root, and here there are no roots because the graph does not cross the x-axis. The discriminant is given by b squared minus 4ac, and we substitute the coefficient of x squared for a, the coefficient of x for b, and the constant for c. In the first scenario here, we expect b squared minus 4ac to be greater than 0 because there are 2 distinct roots. Here, we expect the discriminant b squared minus 4ac to equal 0 because there's only one root here, one point of contact. And here we expect b squared minus 4ac, the discriminant, to be less than 0. That is, that it does not intersect the x-axis at all. Here we have a quadratic equation, and we're going to find the range of values for k that's such that this equation has 2 distinct real roots. The first thing to do is to write down the value of a, b, and c, remembering that we have ax squared plus bx plus c. So our a is 9, b is 8, and c is negative 2k. And we want the discriminant that we'll work out in a minute, b squared minus 4ac, to be greater than 0 so that it has 2 distinct real roots. Let's substitute our values into the discriminant. Here we have the value of our discriminant, and we're going to let it be greater than 0 to determine the values of k that satisfy this equation for 2 distinct real roots. Here we can see that k has to be greater than negative 8 over 9 so that this equation has 2 distinct real roots. Another situation where we could use the discriminant is to determine whether 2 lines intersect. Here we have a quadratic, and here we have a linear equation. We want to see whether they intersect without solving the equation. First, let's equate the terms because they both equal y. Now we'll rearrange it to let it equal 0. We don't need to solve this to determine whether these lines intersect and the number of times they intersect, because we can use the discriminant. Here, a is 10, b is negative 7, and c is 1. Here we can see that the discriminant equals 9, which is greater than 0. So we can say that yes, they intersect at 2 distinct points. The discriminant can also be used to determine whether this line here, y equals 2x plus 4, is a tangent to this circle. Let's start by substituting this into our equation of the circle. It already equals 0, so now we're going to expand the brackets and collect the like terms. Here's my simplified quadratic, and I can divide both sides by 5. Now I don't need to solve the quadratic to determine whether this line y equals 2x plus 4 is a tangent. If it is, I expect the discriminant to equal 0. Here, a is 1 because there's 1x squared, b is 2, and c is 1. Let's determine the value of the discriminant. Here, the discriminant equals 0, which implies there's only one root, and therefore y equals 2x plus 4 is a tangent to the circle. Remember, a tangent touches the circle at one point.